All right, let's jump right in. Today, we're getting into the nitty-gritty of the gear that powers pretty much every major control room. We're talking about how professional AV systems seem to cheat physics to get that instantaneous video switching.
Yeah, that's exactly what we're tackling. We're doing a deep dive on the WolfPack DVI Output Card.
Yeah.
It's really the cornerstone of these huge modular WolfPack matrix switchers.
So the big ones, like the 9 by 9 or even the massive 36 by 36
The
systems.
very same. And this specific one-port 1080p card is, the piece that makes the whole thing work so reliably.
Okay, so let's unpack the core challenge here, which is speed. I think
Mhm.
anyone who sat through a presentation with a consumer-grade switcher knows that pain of waiting.
Oh, yeah. The black
The
screen.
black screen, the flicker, that horrible few seconds while the devices, try to talk to each other. It's so jarring.
And it's completely unacceptable in a professional environment. A newsroom, a casino, you just can't have that. The whole promise of the WolfPack is that seamless switching speed. We're talking 100 milliseconds.
A tenth of a second.
Exactly. It results in a clean video cut. Zero glitches.
100 milliseconds is fast, but how do you know that isn't just a really quick flicker instead of actually being seamless to the human eye?
That's where the engineering gets clever. See, the high-performance engine inside doesn't wait. It's firing off the ED spic hops and the HDCP handshakes at the same time, at both the source and the display. But the real secret sauce is the frame buffer.
Ah, the frame buffer. Okay, so what problem is that solving for me instantly?
It hangs on to the information for the input signal, just for a moment. Just
Yeah.
long enough to set the output clock timing.
So it's sort of preloading the image.
You got it.
Right.
By having that data ready to go, the device completely avoids that no signal moment. It forces the output to be clean. That's the difference between a client noticing a glitch and, just seeing a smooth professional switch.
And on that topic of reliability, that modular approach is just huge because these are individual slide-in cards if one port goes down.
You're not dead in the water.
Right. You're not shipping a whole 36 by 36 chassis back for repair. You just swap out one, $250 card? That must save integrators days of downtime.
Days, sometimes weeks. It's system stability built right into the design.
Okay, let's talk connectivity. This is a DVI 1.1 card, which I gotta say feels a little legacy. How does it handle all those weird, older analog displays that clients just refuse to get rid of?
Yeah, that DVI backbone is a bit old school, but it's offset with just massive I/O versatility. The card actually comes with DVI adapters.
The what? HDMI?
For HDMI and for the really old stuff too. CVBS, YPBPR,
Yeah.
even EGA is built to plug into pretty much any infrastructure you'll find out there.
I see the video flexibility, but what about sound? In a big venue, you need dedicated audio routing.
Yeah, and that's why the separate de-embedded audio out is so critical. It's just a standard 3.5 millimeter jack right on the card. It lets you peel the audio stream away from the video and send it to your amps, your mixers, wherever you need it to go. Completely independent.
Now, compatibility. This is where installations go to die, right? We always talk about software fixes, but this system actually uses hardware scaling. Tell me about the DIP switches.
Right, so say the software scaling is failing, or you just have a weird resolution conflict you can't solve. There's an 8-pin DIP switch block right on the card itself.
A manual override.
A manual override lets the installer physically force the resolution up or down. It's that old school guaranteed control that can really save a job when the software just won't cooperate.
And for EDID management, which is, the cause of so many no-signal headaches, what's the simple fix here?
You just force the source to listen to the display. You plug in your screen, you press the little EDID key on the card twice, and that's it. It copies the display's EDID, which kills most of those negotiation errors that can stall a job for hours.
So we've covered the hardware, the speed, the flexibility. Let's talk control. The places this lives, casinos, conference centers, they need rock-solid control options. The sources mention, over 20 different methods?
That's right. For a basic user, you've got the front panel buttons, a web GUI, and of course the free iOS and Android apps. But for the professional integrator, it's designed to play nicely with the big systems.
You mean Control4, Crestron, URC?
Yeah.
The usual suspects?
Exactly. HDTV Supply provides all the drivers for those major third-party systems. But what I find really fascinating is the custom integration. They give you a simple RS-232 script for writing your own drivers.
The example command here is AOPLS 1 and 8 and 16 to switch input 8 to outputs 1, 8, and 16. Why is having a simple, clean syntax like that such a big deal for an integrator?
It just bypasses all the complex APIs. If you need a custom button to do something very specific, you don't spend a week trying to figure out some proprietary language. You just write a simple text command, test it, and you're done. It means faster commissioning and, frankly, lower labor costs.
Super powerful. Okay, before we wrap, we have to mention one critical warning from the materials. This is not a suggestion, it's a hard rule. Do not mix these 1080p DVI cards with 4K cards in the same chassis.
Absolutely not. These are pure 1080p systems. You mix those chipsets, you're asking for major stability problems. You could even damage the chassis. But, they do back it up with a 2-year advanced replacement warranty.
The WolfPack Care warranty, right, ships a replacement within 24 hours.
Correct. So they stand behind the hardware.
So really, the whole point of this tech is to move complex switching from something slow and physical to a near-instant software-defined event. But if the industry has already gotten us down to 100 milliseconds, what's the next step? How do you engineer a way to eliminate that final tiny gap? That's the question to think about, as the entire AV world chases that dream of truly zero latency switching.